Hello and welcome to our YouTube channel Quick Solvers. Here we want to find this right hand limit where x approaches -1 from right for this function where we have the absolute value of x plus 1 plus floor of x over x minus floor of minus x. So we have floor function here, we have floor function here, and we have the absolute value here. So let's see how can we solve this. I focus on simplifying this and then this and then this. If we can do so, I think we are done for this particular question. So let's see how we can find the value of these three functions. If this is the values that x can take, for example, this is 0, this is 1, and this is -1, okay? When we say x approaches -1 from right, it means x is very close to -1, but a little bit greater than -1. So if x is a little bit greater than -1, then x can be something like -0.999999, okay? Something like this. Then it means x is somewhere here, very close to, this is x, very close to -1. And if x is like this, then the floor of x gives us the greatest integer less than or equal to x, okay? So the greatest integer of -0.9999, if we look at here, we can also find that the greatest integer that is less than or equal to x, well, x isn't an integer, but the greatest integer less than x is -1, because the other integers would be -2, -3, -4, which are less than -1. So I would say this equals -1, and that means I can replace this by -1. So this is -1. But how about this floor of -x? Again, x is somewhere like -0.99999, okay? Then -x is approximately equal to 0.9999, and it is very close to 1, but a little bit smaller than 1. That means -x is somewhere here. Again, floor of -x gives us the greatest integer less than or equal to -x. So this is -x. The greatest integer less than -x is 0, because the other integers less than -x is -1, -2, -3, and those are all smaller than 0. That means this equals 0, and that means I can replace this by 0. Okay, so let me get rid of this so we have some space to work on the absolute value now. All right, now we have absolute value of x plus 1. Generally, the absolute value of an expression like x is either x or -x. It is x if x is positive, and it is -x if x is negative. Okay, that means to understand whether we should keep, we should remove this absolute value, or we should use negative x plus 1, we should find that whether x plus 1 is a negative or positive. So let me write it like this. So this can be either of these two values, okay? It can be x plus 1 if x plus 1 is positive, and it can be minus x plus 1 if x plus 1 is negative. So we should determine whether x plus 1 is negative or not. Well, we decided that x is something very close to minus 1, but not exactly equal to minus 1, a little bit larger, bigger, greater than minus 1. So then x equals minus 0.9999. Okay. Just for the sake of simplicity, let's just assume that x equals 0.9. Then from this, I can conclude that x plus 1 is something close to minus 0.9 plus 1, and it's something like 0.1, or to be exact, is something like 0.00001. But whatever it is larger than 0. It is a positive number, okay? That means this is the case. That means I can replace the absolute value of x plus 1 by x plus 1 itself, okay? Now I can rewrite the function and find the limit, okay? So I can rewrite this as the limit of absolute value of x plus 1. We know it equals x plus 1. We know this Floor function gives minus 1. Then in the denominator we have x, and then we have x minus, and the Floor function gives 0, okay? Where x goes to minus 1 from the right, okay? And this equals the limit of x, because this minus 1 and this plus 1 cancel out each other. So we have x, and in the denominator we have also x, where x approaches minus 1 from the right, okay? And well, again, this x and this x cancel out each other, and what is left is just 1. And that means this is the right choice for this particular function.